In this section, we're going to talk about pointers. Now, coming from a Java background, pointers are going to be kind of the big new feature for us in C, right? There's going to be no concept that we can kind of relate pointers to from Java. Now, the basic idea of a pointer is that we're going to have the ability to create variables that basically reference another variable, right? So instead of, basically variables being independent, one will actually be able to know about another. So let's go ahead and dive into this and see what that really means. So first of all, think back to kind of how we're used to dealing with variables. Normally we think of variables as basically going to be a name that refers to some piece of data, right? And so your piece of data could be an array, it could be an integer, it could be a float, it could be many things, right? But we need to have some sort of name associated with it in order to actually use it, right? Names are useful. Otherwise, we can't perform operations over the data that we have out there. Now, thinking back to some of the previous sections, one of our kind of new considerations in C is that each of our pieces of data, right, that's bound to a name, right, bound to a symbol, bound to a variable, has an address somewhere in memory, right? Everything has to exist somewhere. And we've already looked at a little bit this idea of, I can actually do things like look up the memory of a variable, right? Basically say, okay, what is that number that corresponds to the space where that piece of information is being stored? And then once I have that, go in and maybe make a change. And we did something like, for example, +1. What that did is it went and looked up the piece of data next to the thing we had just looked at. So that can be very useful. Now, in addition to that, right, in addition to directly kind of looking up an address where something is stored and manipulate it, we can actually look up the address of a variable, right? Look up the place in memory where it's being stored, and take that to be actually a value itself, right? And store that into another variable. So let me actually just say that again. We can look at a variable, grab its address, and then store that address into another variable, right? So all of a sudden, right, maybe you can think of, maybe you have variables A and B, right? Say A is something that stores, for example, the number 10, right? So it's an integer type variable. But then in B, what I can do is I can actually say, okay, I'm going to look up the address where A is stored, right? Maybe it's stored at address 100, and then that 100 is actually going to be stored into B, right? And B will be kind of a special type of variable. It will be called a pointer type. It will be essentially an integer pointer, right? So that second variable, that B variable, it's not storing, a number per se. It's storing the address in memory where I could go if I wanted to look up that number that was stored in the first variable, right? Kind of a note here, right, is that we think of variables, right, as storing values, an address, right, that number in memory, right, that's a value too, right? It's an integer, right? It's just a number, but it's special in that it tells us, something specific. It tells us that if I go to this place in memory, well, then I'll get back out that piece of data that was stored at that variable whose address I looked up, right? So you have to be just a little careful here, right? Addresses may just look like integers, right? But they're special because they're just telling us, where is something. So let's take a look at some operations that we can actually do over these special types of pointer variables that store addresses. So the first thing we can think about doing is maybe we have we create a pointer variable, right? We'll see syntax for that in a moment. But if I have a variable, right, that's basically typed, right, or set up to store an address, right, to store a pointer, well, then it makes sense I should be able to store an address in there, right? So that's kind of the thing we had done in that example a few sections ago where we had those PN variables, right, and we had them set equal to some stuff, and we used some special symbols, right? Basically what we're doing is we're grabbing the address of one variable, storing it into another variable. So that's kind of our first operation that we can do, right? It's the first bullet point over here. The second thing we can do, right, which you also kind of demoed, is, okay, I can go to that address that's been stored in a variable and modify it, right? So I can do +1, -1, I can do a couple different things kind of to move around that address, right, to make that address refer to things other than the first thing it referred to. So that's the second thing I can do. Generally, this is called pointer arithmetic, right? We're doing some direct manipulation on a pointer. The second thing I can do, right, and these are kind of going to give us special symbols. This is where it says referencing and dereferencing. That's actually referring to these over here, these two symbols here. But referencing basically is going to say, okay, I need to have an operation, right? An operator, right? There's actually going to be this AND symbol here that goes to a variable and gets back or returns the address of where it's storing its data, right? And if you think back to that previous example, that's what we had. We had that ampersand symbol in front of a variable, and we got that address out of it, right? And then we did things like, we did a +1, right, to change it or something like that. But that's kind of the first kind of key operation we need in order to deal with pointers, is just have a way to look up the address from a particular variable. The second thing we have is dereferencing. And dereferencing is going to be this star here. So the star is basically saying, okay, I have a variable that contains an address, right? A number that talks about where in system memory something is being stored. Well, go to that address and actually look up what's there, right? So find the actual value that's being pointed at, right? And that's what we do with the star operator, right? The star operator says, take an address, go to the contents, right? Versus ampersand, versus the and symbol, right? It's saying go from the variable, right, such value, to the address of where it's being stored. Notes here real quick. I had this kind of as a big warning here. A lot of times people get kind of confused and they think that, oh, this is being used as an and symbol. It's not, right? It can be used for and, right? You probably use them a lot, in logical statements where you have maybe double ampersand, right? To check to see whether two things are true, right? Short circuit anding. But here, right, just the one for us in front of a variable name is going to mean look up the value, look up the address of it, right? It's not going to mean anything to do with logic. So be a little bit careful there. One thought here, I have it in my other little box up here, and I'll just read this question to you guys. Would it make sense to be able to assign a generic integer into a pointer? So maybe think about that for one moment. It kind of does, right? It kind of does, right? If we somehow knew that magic number where something was being stored, then yeah, we could, just assign it into a variable, right? And that variable would all of a sudden have, access to whatever is being stored at that particular address that we, assign to it. But it's kind of hard, right? Because we need to know what exactly is that number, right? That address where something's being stored. So typically we don't just, assign an integer into it. Typically what we have to do, right, is use that and symbol, right, in order to say, okay, I'm going to look up the address from this particular thing, right, rather than hard coding in something. On the other hand, right, if you're curious, right, you could always, assign into a pointer, right, some, integer and say, okay, maybe I want to see, what is that position 10,000 or something, right? So you could do that arbitrarily if you want to, but it's, not too useful for us. Okay, so going down here, a little bit more discussion, right, on those two symbols. So the ampersand, right, we put it in front of a variable, right? For example, over here, right, we have and x, and what that's saying, right, is go and look up the address of where x is being stored. The rest of our line there is saying, okay, you've looked up where x is being stored, right? You've looked up an address, right? This thing under here, right, is going to correspond to an address, right? Let's just do ADD, right? And then that's being stored, right, into our y value, into our y variable. Over here, right, there's some additional kind of notation, terminology. There's this idea of an R value. An R value is basically something that goes on the right side of your equal symbol, right? So the equal symbol that we use in programming, right, is not the equal symbol in math. It has kind of a specific meaning and specific order, right? Things basically go from the right-hand side to the left-hand side. So the right-hand side is basically values or expressions, right, that you can read, right, that have some bit of information coming out of them, right? So when I have that and x, the value there, right, is going to be that address, right, of where x is storing its information, and then that data, right, gets thrown over to y. Now, the fact that that is actually data on the right-hand side, right, that's what we call an R value. You can think of it as maybe being like a readable value or something, right? There's something actually there. Versus we actually have something called an L value, which typically goes on the left-hand side, and the L value isn't a piece of information per se. What is it's a place where I can actually put stuff, right? So location of where data can be stored, and that's what we'll call an L value, right? So that goes typically on the left-hand side, right? That's our Y, right? Because Y, right, we don't really care what's inside of Y. Y has to exist so we have a place to put that address. It's the location of, some storage information, right, called Y. So just some terminology there, right? Our R values and our L values. Down here, right, we can see you have another example. So here we're saying something like, okay, star Y equal 5. The way I read this is actually saying, okay, Y, right, maybe Y is a variable the way I talked about earlier. Y is something that stores a pointer. And what happens, right, if I have, this variable called Y that's pointing at X, right, and I want to actually use that to change the value in X. Well, the way I do that, right, is I go star Y, right, because that star is a dereference. That star says, look up the address where that Y is storing, right? Y is storing the address of X. And then once you look it up, then do something to it. So that overall line there, star Y equal 5, that has the effect of going to the address where that Y knows about, basically opening it up, and then storing the value 5 into it, right? So we would be indirectly able to store a value into X, even though we don't really have X, right? You just have Y, and Y has the address of where X is stored. So we look it up, use it to look up the address, right, or look up the location, right? And then once we have it via that star, we put the 5 in there. So we have a kind of an indirect way, right, to change the value inside of X. These star and ampersand operations, right, those are really kind of, they're almost inverses. Almost, not quite. There's actually a couple of different stars. The star here we're talking about, right, is the dereference star. There's actually a second type of star, which you'll see in a second. These two operations, right, basically they go together, right? They're the opposites, right? So if I have something like this over here where I have, a variable called P, and I have star P, basically what it's saying is, okay, star for a variable goes and looks up what's at the address that the variable knows about. And then the ampersand over there, right, is basically saying, okay, for a variable, right, go and look up the address that, that thing is being stored in, right? So basically those two things cancel out, right? I cancel those two symbols, cancel each other out because they're doing opposite things. Same for the bottom one, right? So we have some variable x, and so it should make sense, right? If we look up the address, well, once we look it up, if we do the star to look at what the address actually has, well, we're back to x.